Good day, everybody, and this lecture is an introductory to the course titled Event-Driven Programming. And the presentation outline is as follows. We are going to have an introduction to event-driven programming. And then we're going to talk about typical graphical elements, and then control-driven versus event-driven programming. And then we'll have events and events generation, and then what is event-driven programming, and then why is it popular, and then we'll look at few vocabularies. Now, to introduce this course, we want to talk about a computer program as a list of instructions that the computer works through in a logical sequence. And this sequence that is walked through is executed in a logical way, and it is written using a programming language, and there are different programming languages, and each of these languages have got their own rules and syntax. And what we are going to use for our course is Visual Basic, which is known as an event-driven programming language, and they call it a general purpose language because it can be used to create different kind of applications. Unlike other types of languages like Fortran, which are used for computing or scientific applications, and they're specified or they're specialized to some domains. And we have to understand that nowadays, modern computers nowadays use the graphical user interfaces. We call it the GUI. Now, this GUI helps a user to instruct a computer or to execute a program using this graphical, should I call it, interface that comes between you and the program or the computer. Now, the graphical user interface, or GUI, would stand for graphical, which might not necessarily be limited to only text and characters, but then all things like windows, menus, buttons, all the graphics that come to us through a program that present themselves for interaction, they are under the graphical realm. And then user is the person who is using a program, and the interface is the way to interact with the program. Now, so a graphical user interface, it's like a user trying to use a program through an interface which is graphical. Now, GUI has icons on the computer screens and a mouse and other devices to control the pointer or which are used to operate the computer. So a GUI is nothing but an interface that would appear on a screen, or that would render itself available for you to interact with the program. So we have very many types of interfaces, and we'll look at them. So an interface is made up of objects or controls such as a button or a combo box, and events happen to the object. We'll come to understand that. But then what I want us to understand now is that before we had so many computers as we do nowadays, computers used to run instructions and we never used to see or have the chance to interact with the computer. And these instructions were executed in a logical way or in a sequential way behind the scenes. But nowadays, we are given the opportunity to interact with these computers, and we use the graphics that is presented to us. Now, uh, in computer, this ordinary setting, for example, if you're using any computer running any operating system, that operating system is graphical in most cases. Unlike, of course, we have the command line systems whereby somebody has to pass in commands. We have the graphics, and these graphics always help us to interact with these computers. So, number one, we're trying to say that typical graphical elements, number one, is a window or a window. You know, Bill Gates is the richest man because he came up with Windows, and Windows is nothing but trying to present a computer program that was previously in command line, but you present it in Windows. So every action can be executed through that graphic, which is a window or an icon or a picture or an image or some words. So a window is a graphical element which is very important. We are saying here that window, it's a portion of the screen that serves as a smaller screen within the screen. Number two, we can have menus, a list of alternatives offered to users. Now, in many cases, we have so many types of menus. I think it is easy for us to really relate, because nowadays, if you want to use a computer, you have to press somewhere, and then we have a list of menu items that is presented to you for you to select what you really want to do, and then we have to press buttons and many other things. So we are having nowadays these options presented to us to enable us to interact with the computers. Previously, as I did say, the list, the programming style was control driven, meaning that a list of instructions are performed in order. You write a program, you either start with the header files and then you declare things and then the instructions. So when you run the program, it runs step by step in order until it comes to the end. So that is something close to as a control driven paradigm or programming paradigm. But what we want to do in this course is what we call as event-driven programming style. So here it states that objects that can fire events and objects that can react to events. It means that we're not going to have a list of instructions, but we're going to be able to, for example, like put together objects that can be used to either fire some events or trigger some events so that the computer can do something. So that means that we're not going to have a sequential execution of programs. We are just going to have the program executing only what is being triggered or what is being pressed or what is being what event is being undertaken. So that is where we have a difference between the control driven and the event driven. Now the next thing to happen is next thing in the list. This is just a sequential way, and then the program performed by one agent, the computer. And on this other side, we have that the next thing to happen depends on the next event. So you can decide to do this action now, and then you perform another activity here, or you do another event this time around here. So you don't have to go through that sequence. That means that you're not able to execute everything. You just do what you want, and the computer will just perform the actions related to what you requested for or what you've really tried to do. So program is interaction between user and computer. So program is performed by one agent, the computer. So the program was in charge of everything here, and here the program is interacting between you and the computer. So that is how now the aspect of human and computer interaction is being brought into play here. So we, in most cases, would generate events, and then the computer will react to the events and give us the solutions to what we have been trying to do. Unlike previously, where control had to run from top to bottom. So modern GUIs like MS Word interface require the use of event-driven programming. So whenever you see any program which presents itself as a graphical image, and if you can get action through either pressing or clicking something or dragging something or even typing something, then you get to understand that you are trying to do what we call as generating some events. So all these programs that we nowadays have an interface and which require the use of event-driven programming. So event-driven programming is something that is very important in today's programming world. So programs with GUI often use event-driven programming. So if it's graphical, then just know that there is some event-driven programming that has happened. It can either be in other language like Java or C++ or VB or VB.NET. It is an event-driven programming. Now, programs wait for events to occur, and then they respond. Let me just give a small example. You want to log into a Gmail, you type in your word, you have to press enter, or clicks or sign in or log in. So by you clicking, you are trying to instruct the computer or generate some event, and that event will be handled by some event handlers, and then of course some action will be done, and then hopefully you'll be allowed to log into your email or your Facebook or any other program. So programs wait for events to occur and then respond. So GUI is event driven, and we generate events, and sometimes even the system itself can generate its own events, and it knows how it will handle them. Now, firing an event when an object generates an event. So when an object generates an event, so an event is fired. Then there is another object that is used to listen or to really monitor and see, okay, an event has happened. So once it has happened, now some method is executed, meaning that some response is given to the person who has either utilized this resource or this computer. So we have a listener and an event handler. This event handler is nothing but a method that responds to an event, or it can be a function. Now, events occur. An event occurs whenever an event listener detects an event trigger and responds by running a method called an event handler. And modern operating systems and programming languages contain facilities to let programmers set up event listeners. An event trigger can almost be any activity. So we are seeing here very important things, that an event has to occur whenever a trigger is detected by an event listener, and then an event handler would run a method or a function, or it will run some code, and of course you will get what you want. And that's why we are saying that modern programming languages are going to give us the facilities to let us program our programs using these features, and programmers will set up event listeners. Now, that is why this course will use Visual Basic, because Visual Basic is going to give us lots and lots of event listeners, and we are going to arrange them in a good way, and we'll be able to program them, and then the methods will of course respond, and some action will be done. So an event can be anything close to the following, more especially when it comes to us and computers interacting. You can either be moving a mouse, or you can touch the screen, or you can press a key, or it can be tilting your tablet or phone, or it can be clicking a button, or dragging a mouse, or pressing a key on a keyboard, or it can either be when a printer wants data. Maybe you sent something to be printed, a document, and then the printer maybe has been printing something, it finished, it requires something. So all these events are triggered by some activities. So activity would help us know some of these events. For example, each one of us nowadays might have access to a smartphone. A smartphone, if you do anything, you must either press an icon, or drag an icon, or click on an icon, or you can even tilt the phone for something to happen. All these are activities which trigger events, and they are all captured, and they are analyzed, and then some responsible or some methods are of course executed based on what you did. Now, an event handler is what we call in programming a method that is activated when the event trigger occurs. So events are an important part of programming, allowing the computer to respond to requests by a user. That is very clear. And events can be used for many other purposes, such as controlling or background alarms, or sensing, and printers, and many other things. So event-driven programming goes beyond the GUI, let me say that, to even more complex systems. And real-time systems, for example, that we know are good examples of event-driven system is a vending machine. A vending machine, you want something, you insert some money, and then you get what you want. A TV, you want something, you have to press, for example, the remote, generate some, you trigger something, some action is done. Either you're changing stations, or switching on, or off, or something like that. These are event-driven systems, or any modern windowing program like PPT, Word, etc. Yes, you want something happen, you click, things happen. So you generate events, or you trigger something to happen. So that is what event-driven programming is. Yeah, here's a good example to show us what happens. Now we have an event source. This event source notifies the handler, and the handler modifies the object. That's what we just talked about. So events are key to event-driven programming. Now, what then is event-driven programming. I'll just read it here. It says that event-driven programming is when a program is designed to respond to user engagements in various forms. So if you're trying to put up a programmer that is going to interact, that is going to help or present itself to users, and users are going to interact with the system, then that is an event-driven program. So it is a programming paradigm where the flow of program execution is determined by events. Events are any user interactions, such as click, etc. And flow of control of the program is entirely driven by responding to events. And a program is driven by responding to events. So it is a programming paradigm that helps us develop systems that are going to be interactive. That's what I'll say. So what I'm trying to say is that there's a possibility of us developing a graphical user interface with very many controls and enabling a user to perform action or any desired action. That is event-driven programming. And why is it popular? Nowadays, we have mobile phones, desktop applications, and people are actively engaging these systems. So this is the right time for us to learn this. And it is easy because a very complex system can be really like customized and then presented in a very simple way. So this is event-driven programming, and the large majority of programming languages support event-driven programming concepts. Although some are better designed to implement these kinds of actions, so some are easier to implement, and others, of course, are a little bit complex. So that's why event-driven programming is popular, and it's very, very important. So for us to be able to understand these introductory concepts, we need to get this vocabulary. What is an event? An action that causes something to happen. An event-driven program is a program designed to run blocks of code or functions in response to specified events. Event handling, an overarching term for the coding task involved in making a program respond to events by triggering actions. Event listener, a command that can be set up to trigger an action when a particular type of event occurs on a particular user interface element. A user interface, the visual elements of a program through which a user controls or communicates with the application. And then user elements are on-screen objects, buttons, images, text, menus, and everything. So this course, by the end of the semester, we are going to create an interface. And we're going to have that interface having very many user interface elements like buttons, images, text boxes, pull-down menus, screens, and many other things. And using these things, people are going to generate events. And these events are going to be handled by the listener. And we're going to get, of course, results out of that. That is what Visual Basic will help us do. And of course, these concepts can be used in Java and many other programming languages. And hoping that this is just at the beginning, let's keep on reading to understand what event-driven programming is. But to make it simple, let's think of it this way. We're supposed to develop a system that has an interface, that has controls, and these controls are going to help me as a user and you as a user to interact with the program, with the application, and the process of us interacting, we keep on triggering and generating events, and we are going to get a response back. That is event driven programming. Thank you.